Hello viewers, I am Kausalya. Today we are going to solve problems 5 and 6 in exercise 13.3. Problem number 5. A container shaped like a right circular cylinder having diameter 12 cm and a height 15 cm is full of ice cream. So here we have a container whose diameter is 12 centimeter and height is 15 centimeter. So obviously this is a cylinder, right? And here they have clearly mentioned right circular cylinder. So just draw the cylinder and write down its parameters. So here the diameter is 12 and the height is 15. Now what happens? The ice cream is to be filled into cones of height 12 centimeter and diameter 6 centimeter having a hemispherical shape on the top. So we are filling ice cream from this cylinder to a cone, right, whose top portion is covered with a hemisphere. So here what is the height? Height is 12 centimeter and what is the diameter? The diameter is 6 centimeter. Now find the number of such cones which can be filled with ice cream. So here we need to find the number of cones required to fill the ice cream which is in the cylinder, right? So now we are going to place the ice cream in the cylinder to the cones. Now we need to find how many cones do we require to finish the ice cream in the cylinder. Okay, that is the question. So again, here we are discussing about the cylinder and the cone. So volume of this ice cream which is filled in the cylinder is equal to the volume of cone multiplied by, we don't know how many cones we need to finish the ice cream in the cylinder. So volume of the cylinder is equal to some x times x is the number of cones multiplied by volume of the cone, right? So here let x be the number of cones required. So volume of the cylinder is equal to x times, okay, we don't know how many cones we need, so x into volume of one cone. Now the volume of the cylinder is given by the formula pi r square h, and here volume of a cone. So how does this cone look like? This cone has the shape of a cone as well as a hemisphere. So volume of a single cone includes volume of a cone by shape and volume of a hemisphere. Now you see x into, so volume of one cone is nothing but volume of a cone plus volume of a hemisphere. Now just write down the formulas. So volume of a cone is 1 by 3 pi r square h and volume of the hemisphere is 2 by 3 pi r cube. Just write down the formula. Then since here we are discussing about, you see this term contains r and here also r and here also r. So just write it as r1, r2 and r3. For your convenience, you can just make a statement. Let r1 be the radius of the cylinder, r2 be the radius of the cone and r3 be the radius of the hemisphere. So that's it. And again here we are having two heights, right? So here I had mentioned this as h1 and this as h2 to have clarity. That's it. Now just substitute the values. So here you see I had made a statement. R1 h1 is the radius and height of cylinder, R2 h2 radius and height of cone, and R3 is the radius of the hemisphere. Now just substitute the values. So pi into the value of R1. So what is the value of R1? You see here, this is your R1 and this is your H1. So R1 is 12, not 12. Here the diameter is 12. Therefore R1 is 12 by 2. So 12 by 2 whole square into H1 is 15, which is equal to, you see here in these two terms pi is common. So take this pi outside. So pi x into 1 by 3. What is the value of R2? Again here the value of the diameter is 6. So radius is 6 by 2. So here you see 6 by 2 whole square and h is 12. Plus again 2 by 3. I had taken this by outside. What is the value of R3? So again you see this diameter is common for the cone as well as for the hemisphere. So again the diameter of the hemisphere is 6. Therefore the radius is 6 by 2. So here I had written it as 6 by 2 whole cube. So now this pi and pi get cancelled, and again 12 by 2 is nothing but 6. So I had written here as 6 square into 15, which is equal to x into again 1 by 3, and 6 by 2 is 3. So 3 square into 12 plus 2 by 3 into 3 cube. Right. Now this 3 and 3 square they cancel, and this 3 and 3 cube they get cancelled. So finally you see 6 square into 15, which is nothing but 36 into 15. And here x into 12 3s are 36, and here it is 3 square. So 3 3s are 9 and 9 2s are 18. So when you add 36 plus 18 gives you 54, and 36 into 15 gives you 540. So we need number of cones, that is x. So x is given by 540 by 54, which is 10. Therefore, the number of cones required is equal to 10. So we need 10 cones to completely fill the ice cream which is in the cylinder. So we need 10 cones to empty the ice cream which is present in the cylinder. That's it. We will proceed with the next problem. Problem number 6. How many silver coins 1.75 centimeter in diameter and of thickness 2 mm must be melted to form a cuboid of dimensions 5.5 by 10 by 3.5. So here we have a silver coin whose diameter and whose thickness is given, and we are melting some silver coins to form a cuboid of this dimension. Here we need to find how many such silver coins we need. Okay, this is just reverse of the previous problem. There we have a big cylinder filled with ice cream, and we have transferred the ice cream from the cylinder to the cones. But here just reverse. We have small coins, and we are going to melt these coins to form a cuboid of this dimension, and here we need to find how many coins do we need. Right? So here this is a silver coin whose diameter is 1.75 and whose thickness is 2 mm. So obviously this is a cylinder with some diameter and some height. So coin is in the shape of a cylinder. And next, number of coins we have to find, and this is the dimension of a cuboid, right? 5.5 by 10 by 3.5. So again here, let x be the number of coins required. And here the diameter of the coin is 1.75 centimeter. So radius is diameter by 2, which is 0.875 centimeter. And height is 2 millimeter. So here it is in centimeter and height is in millimeter. So I am converting this millimeter to centimeter. So when you divide 2 by 10, it becomes 0.2 centimeter. So this is the dimensions of the cuboid. So here everything is in centimeter, right? This is in centimeter, centimeter and centimeter. Now, we don't know how many coins do we need. So let n be the number of coins. Sorry, here I had mentioned it as x. So let it be n. Let n be the number of coins. So n into volume of each coin is equal to volume of the cuboid, right? Can you understand the statement? Because we are melting some coins to make a cuboid. So obviously volume of the coins should be equal to volume of the cuboid. We don't know how many coins we need. So I am writing it as n. Okay, here n may be 10 or 50 or 20, whatever may be. So n represents the number of coins multiplied by volume of each coin, so that we can get the total volume. So equal to volume of the cuboid. So again coin represents a cylinder. So the formula is pi r square h and volume of the cuboid is L into B into H. So again here we have 2H. If you need, you can write it as H1, H2 and you just make a statement. H1 represents the height of the cylinder and H2 represents the height of the cuboid. Right. Now just substitute the values. So we know the value of radius and height of the coin, which is cylinder. So here we have clearly written. So substitute the values and here the dimensions of the cuboid, which is directly given in the problem. Now this 7 and 0.875, we can cancel 875 by 7. So when you cancel, here comes 0.125. So anyway, I need n. So I am moving these terms to the right hand side. So here they are in the multiplication, that is numerator part. So when they move to the right hand side, they occupy the denominator. So here they occupy the denominator part. Again, in order to remove the decimal points, okay, just count how many decimal points are there. So in the numerator, you see I have only 2, but in the denominator I have 3, 3 and 1. So 3 plus 3, 6, 6 plus 1, 7. So I have to multiply by 1 with 7 zeros. So I am multiplying and dividing by 1 with 7 zeros. 1, 2, 3, 4, 5, 6, 7. Right. So here the next step is we will be removing all the decimal points. But in the numerator, I have only 2 digits after point. So only 2 zeros will be removed. Then the remaining zeros will follow. So when 2 zeros are removed, then I will be having 5 zeros. So here you see in the denominator all decimal points are removed and the numerator the decimal points are removed and here I am having 1 with 5 zeros. So again you just simplify. Finally, I am having 4000 by 10. So when you solve here, the answer is 400. Therefore, the number of coins required to make a cuboid of the given dimensions are 400. You have to melt 400 coins to make a cuboid of such dimension. So that's it. If you have any doubt, let me know in the comment section. Thank you.